Right, please, I am zooming to even those at home. Right, now looking at our yesterday exercise, hopefully you never had challenges, right? If please you have any challenges, let us communicate so that we move forward. Now, let me check who is this one. Who is that? Which person? Okay. Now, the challenge is if you had given me that information, yes, I could have scheduled it here. So it means to say what I can do, you can give me that question, and then when I am done with this, I can look into it, right? Okay. Now, today we want to look at another function, which is the exponential function. On the exponential function, this function will always lies above or below the horizontal asymptote. When you have the asymptote, now the effect that we're talking of the asymptote, it is not anything new. It always lies above or below the horizontal asymptote. It is an increasing function if the y value increases as x increases. And it is a decreasing function if the if the y value decreases as x increases. Now we are going to look at generally the exponential function. It has this format. The exponential function has this format: f in x, which is a b to the power x plus q. That is where b is greater than 0, and b must be different from 0. It can be anything equal to 0, right? Now we want to look at some to demonstrate how an exponential and how an increasing or decreasing function looks like. Right, let us look at the first diagram here. We have a function of f in x which is equal to b to the power x. Now, that is if we are going to analyze the two situations. If b is greater than 1, that is an increasing function. It is increasing if we look at the graph. As the values of x increase, let us look at this one. If the value of y decrease, if we go down the y value, we tend to the left along the x value. This one is an increasing function. Its gradient is always positive. So the increasing function, it is a function whose gradient is positive. Now, when we look at the gradient, if we start from there, we say change in y, which is negative, over negative, that will be positive. This is an example of an increasing function. It looks like this. It goes on. Now, our line of asymptote, it is going to be the x-axis. And then it goes up here up to infinity. On a decreasing function, that is if b is a number, or should I say b is a fraction between 0 and 1. This one, if b is greater than 1. If b is greater than 1, it means to say it can be any number that is greater than 1, not equal to 1. Now here, if b is a fraction, if it is half, 1/3, 1/4, whatever, as long as it is a fraction, as it is a number between 0 and 1. Now, if you look at this type of graph, if we go down there, here x, if we go down there along the y-axis, y is negative. But now to go to our graph, you turn to the right. So it is negative over positive. This one is a decreasing graph. This is an example of a decreasing graph. Are you all following there? Great. Owen, are you following? Owen?
Yes, sir.
Okay. Now, let us go on to the next one. Now, like we did with all other graphs, we want to find, let us say in this case, an increasing function. This is what I talked about. As x increases, that is, x increases, so does the y value. As one increases and the other one increases, it means to say that is an increasing function. Now, let us look at one important part, the y-intercept. Remember, take note, when we are talking of the y-intercept, the x-intercept, whatever, these ones, when we are looking at the y-intercept, the x value will be what? Equal to 0. I'm getting the point. Right. Now, on the y-intercept, if we take the function, let us say y is equal to b to the power x. Right, if we take b to the power x, this must be an x. Now, on the y-intercept, x is going to be 0. So meaning to say, in the position of x, we plug in 0 here. Any number raised to the power 0, what does it give us? 1. So it means to say, the y-intercept, it will be 1. Always take note, the exponential function, if it is y is equal to b to the power something, and we don't have any other number here, this will always cut at 0, 1. Now, so meaning to say, so y is equal to 1, anything raised to the power 0 is 1. In the case where a is equal to 1 and the q is equal to 0, the y-intercept will always be at the point 0, 1. As long as our value, because when we look at our function, we said a, take note, even on the previous numbers that we had, when we looked at the cubic function, quadratic function, in grade 10, we never talk about the cubic. On the quadratic function, you noticed we looked at a times something. We said it gives us whether it is a smiling graph or a sad graph. When we looked into the hyperbola, we also had this a, and this a gave us the shape. Is it in the first and the third quadrant, or second and fourth quadrant? Now, in this one also, we still have an a. Now, when we're looking at this a, we are going to be, now in this case, we are saying a, if a is 1, it also helps us. This a will always be there in all functions. Now, in the case when a is 1 and q is 0, the y-intercept will be at 0, 1. Let me stop there for a while. Are you following? Great. Now, the values of a and q shift the standard exponential graph as follows. Now, if a, now the sign of a determines, the sign of a determines on which side of the asymptote the graph will lie. if it is positive, it will be above the line of asymptote. If it is negative, it will be below, right? If A is positive, which is greater than 0, the graph will lie above the asymptote. If A is negative, which is a negative number, then the graph will be below the asymptote. We'll be looking into such scenarios as we proceed. Now, let me just sketch one, but anyway, we'll look at it. Q shifts the graph up or down. If we have got, like in this case, we have got a plus Q. If Q is positive, the graph will move positive along the y-axis. If it is negative, it will shift downwards along the y-axis, just like we did with the quadratic function and the hyperbola. Now, generally, f in x is equal to ab to the power x plus q can be also written as ab to the power they've written. Now, in the position of f in x, they only wrote y. It is just the same. You remember that? Okay. Can we move on to the next one? Okay. We want to look into steps of how we sketch the exponential graphs. Now, on the steps on how we sketch the exponential graph, check if the graph is above or below. Now, how do you check? You look at the value of A. If the value of A is positive, any number that is positive, 2, 3, 4, 5, 6, you know your graph will be above. If it is negative, let us say -2, -3, -2, -3, any number that is negative, it will be below. But this particular situation, we don't normally see it, but it's there in life. You may meet it. That is why I'm talking about it. Okay. Now we want to see if we have, so that was number one. Number two, check if the function is increasing or decreasing. Now, if you are analyzing whether the function is decreasing or decreasing, increasing or decreasing, you analyze whether when x increases, the y value increases. But in this case, if you look at the gradient, change in y over change in x, it will show that it is decreasing. Because if we start there, you say negative over negative, this is decreasing. If you start there, you say negative, negative. When you go to the right along the x-axis, you're going positive. So it is negative over positive. It will be a decreasing function. And b will be a fraction. Now, if always b is a positive number, it is an increasing number. It is an increasing function. If b is a fraction, half, 1/3, 2/3, whatever, you know it is a decreasing function, right? Now, let us move on. Now, like in this case, so you analyze whether it is above or below the line of asymptote, whether it's increasing or decreasing. Any questions pertaining to this, what I've said so far, right? Great. Now, let us look on the numbers. Where we are saying the numbers are, is it above or below? Now, if we have our line of asymptote like this, and then this line of asymptote and our graph is something like this, it is below, you actually know that that is the location, and this is the purpose. If b is a positive number and a is negative, if b is positive, a negative, you know that the location of my graph, it is below the x, it is below the line of asymptote. Can I stop there for a while? Any questions? Right. Now, if we have, now when you look at this one, after analyzing whether it is below or above, now when you look at this one, is it increasing or decreasing? This one, is it an increasing or decreasing graph? Decreasing, because you say change in y, negative over, so this one is decreasing. I'm getting the point. Now, if you come on to this one, you analyze if A is a negative number and B is a fraction, our graph will go like this below. This is the line of asymptote. Now, is this an increasing or decreasing? This one is an increasing one. Are you getting the point? Now, those are the two steps. The third step, when you want to find when you want to sketch the graph, you must determine the y-intercept, letting x equal 0. Just like we did with the quadratic, hyperbola, and even this one. When you want to find the y-intercept, x is equal to 0, just substituting. Now, find the horizontal asymptote. On the horizontal asymptote, you will remember that it is the number that you add. Like in this case, on the horizontal asymptote, if you have got y is equal to, let me say, b to the power x plus q. What is our horizontal asymptote? What is our horizontal asymptote? It is q. You remember yesterday we were saying our horizontal asymptote, it will be the number that comes here. So this one is the horizontal asymptote as well on exponential functions, right? Once you have this one, you know it is our horizontal asymptote. And then you treat it the same way we dealt with the hyperbolic functions. Now, you substitute a value for x in order to obtain another point on the graph so that you have the correct shape. Now, you can take any other number so that you have the correct shape, because on the shape, you need to know whether is it curving upwards, curving downwards. So you just take one point and then try it so that it gives you the direction. I'm getting the point.
So,
Hello?
so when you mean you must take any point, can you take any point of the x-axis and substitute it into the equation to get the shape?
Yes. You take
To get the points.
Oh, you are talking about that number 5, right?
Yes.
Are you talking about this number 5?
Yeah.
Right. Let's suppose you are given, because in this, you substitute a value for x in order. If you are given a point, let us say you are given a point, let me just take 1, 1, 4. Now, if you are given any point 1, 4, and you substitute it here, it will give you the shape whether it is curving upwards or it is curving downwards. Say you are given any general point, any point like 1, 4, it can be any. Like here they say substitute a value for x in the given point. If it is 1, 4, if it is 5, 4, if it is whatever, it is the one that you take. You remember when we looked at the hyperbolic functions, you were given a point, and then you use the 1 point to substitute into the general formula, right? Are you following?
Yes, sir.
Okay. If there is an x-intercept, determine the x-intercept by taking by letting y equal to 0. Remember, when you want to find the y-intercept, the x value will be 0. If you want to find the x-intercept, the y value will be 0. That is always the case. Now, you can also use the table method to plot points for the graph, and then you remember the table points that we used in the lower grades 8 and 9. You may take -1, -1, 0, 1, or even 2. You substitute in your equation that were given so that you get these points, and then you plot them. But when they are saying sketch, you only need to know the shape of the graph, and that's all. Are you following? Today we've got so many slides, but I'm sure in our double period we'll make it. Right. Now, what we've been talking about, we are going to concretize this. In the first stance, I was just marathoning through because giving the general outlook. Now, let us look at this one here. We are saying, they are telling us, sketch the graph of y is equal to 2 into 2 to the power x plus 2. Step number 1, determine the shape of the graph. If you are determining the shape of the graph, you look at A. What is our A here? 2. Since A is 2, let me do it this way. Since A is 2, what can you say about this graph? Is it above the line of asymptote or below? It is above because A is positive. Now, what is our line of asymptote? Our line of asymptote is 2. Let us say we have our 0 here, right? And then we say we're going to have our 2 there. Now, with that 2, you will realize this is our line of asymptote. Now, on the line of asymptote, y is equal to q. What is our q? It is 2. Now, from this one, we know that this graph, it is going to be above because A is positive. So it will be found. Now, when you look at this one, now, is it going to curve like this, or it is going to curve like that? Second or first? First, it is this one. Second, it is this one. Is it going to curve? Is it going to follow the first or second? Because of this A, is it going to be? Now, what are you looking at? Now you are looking at this number, at this one. This B is positive, right? It's not a fraction, right? So if our B is 2, this 2 is not this 2. So it implies that, is it going to be like this, or it is going to be like that? The first one.
Increasing.
It is increasing, right? So it will be something like this. Now, with your permission, let me just sketch, because when you are sketching, the graph will be something like this. It draws nearer and nearer, but never comes into contact with the line of asymptote. So this will give us the shape to say it looks something like this, right? So the graph, since A is a positive, the graph is above the asymptote. We now know it will be above. Determine if the graph is increasing or decreasing. You actually say it is increasing because the base here is positive, is a positive number, is a positive whole number, it's not a fraction. So we're saying it is increasing. Right. Now, this one we are done. Step number 3, determine the y-intercept. On the y-intercept, take note we have y is equal to 2 into 2 to the power x. plus 2. Now, when you are determining the y-intercept, what is the value of x? 0. So meaning to say, in the position of this x, you plug in 0. You plug in 0. Now, in this case, you're going to say y is equal to 2 into 2 to the power 0 plus 4. You have plugged in 0 here in the position of x. Any number raised to the power 0, what does that give us? It gives us this 1. Now we are saying 1 times 2, 2 plus 2, 4. Now you are saying this graph here will cut the y-axis at 4. Let me stop there. Are you following? Yes. Step 2, which one? Or here? Here.
Yes.
Okay.
They said A is equal to 2 and B is equal to 2. So was it maybe one of them was negative? Would the graph still increase?
Right. It depends which one is negative. If these two here, if this 2 here was negative, if this was negative, it means to say our graph was going to be below. If we had our line of asymptote like this, our graph was going to come this way, right? It's not going to be the same. Are you getting it? If this 2 was negative, it means to say the graph was going to go below. But if this 2 is negative, it now means to say it is a different scenario. If this one is 2, is negative, in most cases, they will factor it out and accredit to the outside one. Are you getting it? Now, in our situation, in grade 10, you want the one which can be negative will be this one, not that. But if you continue with the mathematics, if this one is negative and this one is positive, factor it out because you consider this one to be, if you factor this one out, that means to say this one will be negative. And take note, this one will be dependent. If x is an even number, this will be positive. If it is an odd, it will be oscillating. So in our situation, you won't be given a situation whereby the base is a negative. Are you getting it? Whereby, but as time goes on with mathematics, it will be there. Then you'll be given a platform. Now you'll be reasoning, basing on this to say, okay, now I can work it like that. That's a very good question. Any more questions there? Right. If A is negative, this graph, what do you think? Do you think the graph is going to go, is going to be increasing? Right. We are saying our line of asymptote is this, right? If this one was negative, so it means to say our graph would be something like this, but it must be a curve. It must be a curve going something like that. Now, when you look at this one, is this number here, is this curve, is this increasing or decreasing? Is it increasing? It is decreasing. So it answers your question. Once it is below, it changes its nature. As here was increasing, now it will be decreasing. Which one? If both are negative, this is what I said. In grade 10, you will not be given this one being negative and this one being negative. But as time goes on, you will be given. But for now, you will need to analyze. If this one is negative and this one is negative, it depends upon the exponent. If this exponent now is an odd number, you will maintain this negative, and this negative and this negative will be positive. But if this exponent now, excuse me, becomes an even number, this negative that is inside, a negative times a negative will become positive, and hence positive and this it will be negative. That one at our level, it is a little bit complicated. You will meet it in future, not in grade 10, not even in grade 12.
So, sir, they will keep A and B separate.
A and B separate. Joshua?
Yes, but they do not multiply them.
Oh, we're running out of time. Right, A and B, you treat them separately, definitely. You treat them separately. Now, if you are kicked out of the meeting, please rejoin, because I've been shown that I've run out of time. So if you are kicked out, rejoin. Right, A and B, you treat them separately, definitely. Right, now let us look into the other one. Is there anyone with a question so far pertaining to what we have said so far? Great. Now we are going on to step number 3. Determine the y-intercept we did, right? Now let's go on to the step number 4. Determine the horizontal asymptote. Now you want to, okay, Litabo. Litabo?
Yes, sir.
Yes.
Sir.
Yes.
Yes, sir. Yes, sir. I stepped to yes, sir. Sir.
I'm not hearing you, please, sorry. Huh?
Can you hear me, sir?
In step 3.
Sir.
You are saying in step 2.
Yes, sir. You see. Yes, right, there's A and there's B now.
You are saying A is what? A.
Sir, there by step 2.
Yes.
Right, they first say A is equal to 2.
Yes.
And then they say B is equal to 2.
Yes.
So now, A is A X or Y, sir.
A is equal to 2 and B is equal to 2, yes.
So now, where do we see A or B on the graph?
Okay. Now, our A, it is this one, the first one that we have here, and the B is this one. Now, the first A they are talking about here, the red one, it is this one. This one will help us to say,
Yes.
yeah, if this one is positive, the graph will go above the line of asymptote. If this first, the red one is negative, the graph will go below the y-intercept. This is the one that you analyze to see whether it is above or below.
Yes.
You use this A. Now,
All right, yeah.
You are clear now?
Yes, sir, I see it, sir.
Okay. Now, on the second one, the second, the B, which is blue, this one, if it is a fraction,
Yeah.
if it is a fraction, that would mean to say our graph will be, will cut there, will be like that. But if it is not a fraction, it's a whole number, it will be like that. This second one, because it is a number, it is a number that is greater than 1. So it is an increasing graph. This one will help us to analyze whether it is increasing or decreasing. Are you clear now?
Oh, okay.
Okay.
Yes, sir, yeah.
Right. Now let us look at the other part. We are saying step number 3 we're done. Step number 4, determine the horizontal asymptote. Now the horizontal asymptote, in our case, we started off with it, right? Which is y is equal to hello ma'am. Yesterday I was this side here. Yes. Okay. Right. Determine the horizontal. This one we did. It was the first thing we did, right? And then we said y is equal to 2. This is the horizontal asymptote. This is what we have, right? Any more questions there? Right. Now, step number 5, analyze another point on the graph to obtain the correct shape. Now, since you are analyzing another point, this is where we had someone asking, are we taking any? We have got 2 to the power, 2 times 2 to the power 2 plus 2. Now, in this case here, in this case, we are actually looking at, oh, this one is an x, it's not a 2. Now, when you are analyzing, in this case, they took x to be equal to 2. But it's not always that you must take x. You can use any. In this case, they took x to be equal to 2 to substitute any value. So they used the 2. 2 to the power 2, what does that give us? 2 to the power 2, 4 times 2, 8 plus 2, 10. So they are saying, okay, the next point, it will be 2, 10. This is the point they used. Now, let us say someone decides to use another number that is different. Just give me any number. Well, nice, 2 big 8. Anyway, no problem. Someone is saying 8. 8 is too big. But anyway, let us use it. Let us use a 3. Okay, you may think that if we use an 8, it is something that is odd. Now, let us use our calculator. Someone has said, if we use 8, if x is equal to 8, 2 to the power 8, what does that give us? Use your calculator. 2 to the power 8. 256 times 2. 512 plus 2. 514. Did you all get that? Yes. Now, the reason why I was saying no, 8 is very big. Because when you are at 8 here, 8 is somewhere, it must go up there. So you can use any number, but don't use a very big number. You could have used 1, 2, 3 numbers that are reasonable. If it is too big, look at it. You don't even have the 500 and something up there. I've done it simply because I wanted to show you that it's possible, but it gives us challenges. Now they used 2. So meaning to say another point, it will be 210. So meaning to say from this point, you now know that the shape is like this. Are you seeing it? Any more cries there? Right. Do not choose, now they are saying it, do not choose a large a value of x. Like you choose 8, 10, 15, 100. Don't choose a large number to determine the additional point. Choose a relatively small number, not a very big number, right? In the second quadrant here. Now, this one you don't have to force it. If it was in this other quadrant, that would mean to say, in this case, you may have had y is equal to 2 to the power 1 over 2. If it was 1 over 2 x plus 2. Then if it was like this, our graph would have been something like, it will have this shape. It will have this shape. Now this shape is determined by the second, because this is the second quadrant. It is, if this one is a fraction, yes? This one? Yes. This is the second quadrant. Here. Yes. Or if you take a negative number. Okay, yes, no, that's okay. Right, let us take any negative number. You are very right. 2 to the power what? Huh?